So it looks like we're live. Wait. Yeah, we are live. So we'll see how this goes. I didn't really plan this very well, and we are still downloading still trying to download the repository, and we may not even get a chance to download the repository. Can't believe their repository is that big. Also, my connection is that slow, but we'll deal with it. I wonder if my... Okay, so let's see. So we're just going to kind of walk through the Pytorch tutorial, and hopefully this video is good. It has excellent connection. Let me look at the stream health real quick. Stream is healthy. Not missing any frames. Okay, we look good. So we're going to walk through Pytorch flow for Vitis AI on the Xilinx's tutorial. We're gonna aim for the Kira board. We're doing Vitis 1.4. I may need to get Pytorch, but that's an easy thing to get. Stop. Let's see. Do quantization. Oh, interesting that they used to train and test data set for, I guess, to re-evaluate it. And then X model. So what we want to, I guess we're going to do the training. That may take way too long with a CPU build, but we'll see. And compile it for our given device. So this is doing MNIST dataset. This is a popular one. You have handwriting, and they are using a very simple neural network to be able to do this. So we have that. We have the host machine of Docker, GPU. We're not using GPU. We don't need that. We don't need that. Okay, I think we're good to go. So we're currently cloning this, and unfortunately, it's gonna. We got a quarter of the way there, and it's been probably 5 minutes. So it may take an additional 15 minutes to finish this up. So I assume we're going to go here. We're going to activate the Docker. I just want to read through these instructions. So we're activate the Docker. We're going to activate Vitis AI Pytorch. Okay, yeah. Activate Vitis AI Pytorch. And run all. So we're going to look at these files while we do this. Okay, so we can do the run all, or we can do these steps individually. So we have Python. Step 0 is normal training. Python utrain 2:1 ttrain.log. We'll execute the training of the CNN and save the train floating point model as a path file called fmodelpath into the folder indicated by float model command line argument. Okay, so we want to probably modify this into CPU instead of CUDA. It's no GPU. Okay, that's good. That's good. Argument will be downloaded to this folder. Cool. Batch size. Epochs, learn rate. Okay, bunch of nice things. Quantization. So this is where we get the kind of Xilinx's Pytorch magic. We'll have to see what that file looks like. So we calibrate and test it. Convert the floating point to a fixed point. Process quantization. Once quantization is finished, by the quant model, the complete list of the command line arguments of quantpy are as follows. Okay, compiling for the target. I wonder if I could just put Kira. We may have to go see how we compile for other targets when we look at the Kira. So if we go back to Vitis AI GitHub, I want to see how we did the Kira, right? So we went here, we did the whole tutorial for Kira, getting started. How did we build for the Kira? Where's the Kira? Kira not here. One of these, right, has the okay, here we go. Setting up the target. Okay, the KV260. Yeah, that's what we want to do. We want to set up the host for this. Yeah, I wish this was clearer because I'm like, I have the model. Okay, so do I just do KV260 and do we call it good? Yeah, do we just want to do the KV260? So if we go look at compile.sh, um, right, you go look at the files, the compile.sh. Okay, so we should have a compiler in here, so maybe we can add the target. So let's go see if we can find that target. Open up another tab and go in here. Farmer, we are farmers. Okay, so we want to go cd opt, right, and Vitis design links. So this must be located here, right? Vitis. I don't know where we, right? So what are we looking for? We're looking for compiler. So where is our Vitis AI? So if I divide it, so if we go back to opt, links, overlay bins, PSA. What do we have here? Nothing. Overlay bins, plus nothing. Okay, where's Vitis AI installed on our machine? Maybe we have to open up in Docker. So we go to cd Vitis AI. We have the Docker. So let's run Docker real quick. See what happens. We got Docker run. We want to run a GPU Docker. So let's just do that. Okay. So we want to do Honda activate Vitis. Caps lock is not useful. Activate Vitis AI and Pytorch. Okay, and opt Vitis AI compiler GPUs. Can we find dash name? I don't know. KV. Are there any KVs here? Okay, we have a KV260 right there. But do we have different ones? I want to see. So we look at the first one, right? The first way. CPU A CD FAH. DPU CAD. What do we have here? We have U200 and U250, so it's the Levo boards. If I go to DPU CAHX8H right here. Other Levo boards, U50, okay. What's the DPU AHL? Is that large? Okay, we got a few different boards here. We have the U280, not the K280, but the U280. Now we go to DPU DVD X8G. Oh, we have the VCK, which is the Versal board. With DPU CVDXH, which is the big Versal board, or the networking one. And then the last one, we have the Z, and that has the KV, the CCU, and the CCU 104. Okay, cool. I was just really curious about that. So that works. Is the stream choppy? The stream looks choppy to me, but it's telling me I got good health. I'm not dropping any frames. So hopefully everything's running smoothly. We're still only 33% of the way through, and I think I still need to download the data set. Okay, so we'll just have to look through the Python why this is all going. So we know how to target our board. That's all I care about, right? Right. That's all I care about. So let's go run all. We're gonna look at all these commands. So first we activate conda, and let's look at train.py. What's Python-u? Does anybody know what the UFlag in Python is? What's Python-u? What is the UFlag? Python, I guess I could just ask Python. Python U option. There we go. Okay, so cd, right, man Python, right? Python dash help. Okay, what's the U flag? U. I'm really curious. U, force binary. Okay, so just unbuffered, standard out, standard air. Cool. I was curious. Okay, now let's go look at train.py. And yeah, they just put it into a log. Okay, cool. So let's go look at train. Hopefully this is, your traditional Pytorch where we're just creating a test, getting our device, creating a model, creating the parameters, getting the data set, train loaders, the epochs. Where's the, are we using a predefined optimize? Where are we defining our network? Train test run main. Train test. Where is the model? Where's the model defined? Model CNN. This in a local file. Let's see. Run application. This is probably just to run the thing. Run DPU. Yeah. That's all our stuff to run the things. Image. Yeah. Common.py. Okay, here we got the network. Okay, cool. So this is the generating the network. And here we're teaching it how to train, what we're looking for the different settings. Testing it. Okay, yeah, useful, man. I need to get back on the PyTorch neural network, but that's super easy. Yeah, we can create a network that way. Okay. And how do we export it? So let's go back to train, right? And save path. float model, the shoe utility rm tree, float model, path, torch.save, model, save, dictionary, state dictionary. So we're just saving the dictionary of the model. Save path. Okay, that's relatively easy. Nothing big there. Okay, let's run on next. What are we doing next in our thing? We've done the training. Now we have quantization, either calibration or test. So let's look at the quantization. That's gonna be interesting. Quantize. Okay. Once again, we call in torch. We're loading the dictionary. We're going to optimize it. So how do we quantize? Oh, so we have a torch quantization process. That's very interesting. And we have the same kind of tester we've done before. But how do we quantize? Like, it's fixed point, right? So how do we determine what fixed point we're doing? Float model, quantization model is probably what we're like. The model is what we loaded in, right? We loaded the model. Yep. Where do we define? Is there X model? Okay. Yeah, but like, how do you pick the fixed point? So we're gonna look at torch quantizer. Let's go look at that. Pytorch. Teach me about quantization, Pytorch. Like this is fixed point, right? Fixed. Dope. Fixed point 32. Or the floating points. Yeah, linear to do quantize. Type for the quantize weight is qint. Okay, so we have like a last parameter. That's the model. So we need to go quantizer, which is a torch underscore quantizer. Okay. Model run args, parameters run args. Model random in. Batch size 1, 2. That can't be the quantization size model, right? It can't be randomizing the sizes. That seems so weird. Model. Because what we have. Oh, this must be something local. The Pytorch. Let's look up this. This might be a Xilinx thing. Okay, yeah. To floats for the quantization. Like how do I pick the fixed point size? That's an important thing to me, right? I'm really curious. Would you just run it and we just assume that this quantization is optimized for Xilinx devices and are like how do I pick the fixed point? Fine tuning, base width, like how many points, how many decimals go in front of the point, or how much data goes in front of the point, how much data goes to the back. Is this somehow maybe optimizing based upon what data is important? This is, yeah, I don't really know that. how does it pick the fixed point, right? If I type in fixed, it doesn't even have fixed point. Default, okay, default is 8, so we're doing 8-bit quantization. I wonder where the decimal fits into that. Or if are we just assuming non-zero values? No decimal. Maybe. Okay. Still at 54%. That is very annoying. We'll just have to see how far we get, and I may have to call the stream early, and we can always continue tomorrow. But yeah, this is all looking fairly straightforward. So next in our run all, which is right here, right? We are going to compile. We're going to ignore all these, and so we go to compile.sh, right? We're going to change the model. We'll have to add our board. Yeah, and that should be it. Make the target folders. Okay, let's see what the target.py is. That's our last thing we would have to change. So yeah, I think we'll have to end this video early. But we'll have to see how that goes. I mean, we could add a KView 260 here. Not a big issue there. To target, arg target. Where's target? Target directory, right? Is that really it? It's just used target. So yeah. Make a target directory, target directory. Okay, so we just got to create a new name. That's super easy. Okay, so I think we can do this for the KV260. I'll have to get it up and running. But yeah, we will, I guess, run through this step by step tomorrow. Tomorrow or another day, and see how it goes. Thanks for watching. This was kind of a just a live stream going through the debugging process. Sorry if it's not too entertaining. I think it's interesting to kind of tackle these tools and figure out how it's going. So join us when we actually run this thing, and I actually have downloaded everything necessary. I think that should be good. Yeah, so I'm gonna try to live stream every weekday. We'll see how that goes. This process, trying to figure out where it fits good. I like the live streaming process, but it's also, I can understand, not the best video for YouTube. But YouTube wants to get into it. So I do want to broadcast both to Twitch and YouTube, and we can see how it goes. But yeah, we'll just probably keep adding these parts and see if we get anything interesting. Maybe we can do a summary video at the end of getting all this running. But hopefully I can provide an example of debugging